Hey everyone, welcome back to the channel. Today, we're tackling LeetCode problem 16, 3 sum closest. This is a medium difficulty problem, and it's a great one to practice for coding interviews. The problem statement asks us to find 3 numbers in a given array that add up to a target sum. If an exact match isn't found, we need to return the triplet whose sum is closest to the target. We're given an array of integers, nums, and a target integer. We need to return the sum of the triplet that's closest to the target. Sounds challenging, right? Don't worry, we'll break it down step by step. We'll explore different approaches and see how to optimize our solution for maximum efficiency. Let's dive in. Understanding with examples. Let's solidify our understanding with a couple of examples. Imagine we have the array nums equal to -1, 2, 1, -4, and our target is 1. Notice that -1 plus 2 plus 1 equals 2, which is pretty close to our target of 1. Now, let's consider another example. Nums equals 0, 0, 0, and the target is 1. In this case, the closest sum to 1 is the sum of the 3 zeros, which is 0. Understanding these examples is key before we jump into solving the problem. These examples highlight different scenarios we need to consider in our algorithm, such as handling duplicates and negative numbers effectively. Let's see how we can tackle this systematically. Brute force approach. One naive way to approach this is using a brute force method. We could iterate through all possible triplets in the array, calculate their sums, and keep track of the triplet with the sum closest to the target. This involves 3 nested loops, making it quite inefficient. The time complexity of this brute force approach would be O of n cubed, where n is the length of the input array. That's not ideal for larger inputs. While this approach is simple to understand, it's extremely inefficient for larger datasets, so it's crucial to find a more optimized solution. We'll see why this is so slow and how we can improve it considerably in the next section. Optimal solution. The optimal approach leverages a 2-pointer technique after sorting the array. First, we sort the array nums. Then, for each number nums at position I, we use 2 pointers, left and right, to explore the remaining array. Left starts at I plus 1, and right starts at the end of the array. We calculate the sum of the triplet nums at position I, nums at position left, and nums at position right. If this sum is closer to the target than our current closest sum, we update our closest sum. Then we adjust the left and right pointers based on whether the current sum is too low or too high. This process significantly reduces the time complexity, making it much more efficient than the brute force method. Let's see this in action by looking at the code. Code implementation. Let's see the code in Python. First, we sort the input array. Then we iterate through the array. For each element, we use 2 pointers to find the closest sum. The key is adjusting the pointers based on whether the sum is less than or greater than the target. This ensures we efficiently explore the possible triplets. We will also handle edge cases to ensure our solution is robust. I'll add comments to the code to make it easy to follow. Show code implementation with detailed explanation, highlighting key parts of the code like pointer adjustments and sum comparisons. Time and space complexity. Now, let's analyze the time and space complexity of our optimal solution. The initial sorting step takes O of n log n time. The nested loops combined with the 2-pointer technique gives us a time complexity of O of n squared. This is a significant improvement over the O of n cubed time complexity of the brute force approach. In terms of space complexity, we only use a constant amount of extra space for our pointers and variables, giving us O of 1 space complexity. This makes our optimized solution significantly more efficient, especially for large input arrays. Engagement break. So, there you have it. We've successfully solved the 3 sum closest problem using an optimized approach. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other LeetCode problems would you like me to cover? Let me know in the comments below. And don't forget to like this video and subscribe to the channel for more coding tutorials. Hit that notification bell so you don't miss out on future uploads. Let's keep learning and growing together. Conclusion. In this video, we tackled LeetCode problem 16, 3 sum closest. We explored both a brute force approach and a highly optimized solution using a two-pointer technique after sorting the array. Remember, understanding time and space complexity is crucial for writing efficient code. This problem is frequently asked in coding interviews, so mastering it is a valuable asset.